Hello and welcome. This is lecture number 2. Go ahead, put today's date at the top of your notes and the lecture number. And today's lecture is going to be about how do we read an instrument correctly, and also the difference between accuracy and precision. All right, and let's start our notes with how do we read a graduated cylinder. So these are those skinny glass tubes with lots of markings on the side, and we use them to measure volume. Now they're typically in milliliters, so we'll assume these numbers are milliliters here. And it might be pretty easy if the water in the tube just created a flat line when you looked across it, but because of surface tension and some cohesion between this water and the sides of the tube, the water typically forms this curved line that we call a meniscus. It's a good word to add to your drawing right there, meniscus. All right, and with the meniscus, we want to measure from the bottom. So measure from the bottom. So you should be redrawing this diagram, labeling that the meniscus, and saying that we want to measure from the bottom. All right, let's actually try to measure this volume of water pictured here. Right there is 20 milliliters, up here is 30, and there's 10 lines in between, meaning that each of these little lines is a single milliliter. So they don't have to label every single line. We can just count. We got 20, 21, 22, 23, 24. So it hits right at the line 24. Now we're going to get real close. So we're going to zoom in and we're going to try to see if it hits exactly at that line or if it's between two lines. If it hits exactly at the line, we'll just say 0.0. And if it's between two lines, well, we can estimate, or we can just say it's 0.5. All right, this, you always want to go one more decimal than the smallest increment of the graduated cylinder. So it's 24.0, that needs a unit, milliliters. And then we're going to say we're going to go one more decimal place. Because it is possible to just look very closely and see if we're exactly at a number or if we're between two numbers. So take a look at this picture here, and I'm going to embed a question for you to tell me what is the volume of water in this graduated cylinder that we have a zoomed in picture of. Okay, so I'll do it now. That's 21 milliliters, that's 22 milliliters. Is that line right there where, and then these are tenths of a milliliter. So we're 21.7, but we can go one more decimal place. To me, it looks like it hits exactly at that line. So I'm going to say 21.70 milliliters. I would also accept maybe 21.69. And those are pretty darn close because maybe it dips just a little bit below that line. But those are, within a hundredth of each other. It may be as low as 0.68, but we can be very precise with these graduated cylinders. All right, the next thing we're going to take notes on is this special word here, tear. What does it mean to tear a scale? We'll often see that word typically on the on button, or a scale might have a dedicated button for tear. What does tear mean? Tear removes the weight of the container. So if we put a mass on the scale and it reads something like 1.25 grams, but then we press that button tear, then the mass will still be on the scale, but the scale will now be reading 0 grams. So the mass is still on there. And so if that's a beaker, we just removed the weight of the beaker. And now, let's see if I can do this. If I was to pour some water into this beaker, but not very much, the weight of the beaker's already been removed, so I'm only getting the weight of the water. So only the weight of water. All right, so let's move on to our discussion of accuracy and precision and the difference between those two things. What does it mean for a measurement to be accurate? So let's imagine that we've got a ball and we want to know its weight. So this ball has a weight, an absolute point. We could put it on a number line here that is its true weight. We then use something like a scale to try to measure that. All right, so here's all the possible weights of that ball. It does have a true weight. When we put it on the scale, we try to measure that weight, but it could be slightly inaccurate, maybe very inaccurate. If we get something like right here, that is pretty accurate because it's close to the true weight. Now, lots of things can throw that off. If the scale hasn't been calibrated correctly, or if we accidentally add something else to the scale, even just air currents in the room, if it's a sensitive enough scale, it can affect the weight that it displays. But if we get a measurement close to that true weight, that measurement is said to be accurate. So let's just, for the purpose of our notes, we'll say accurate is close to true value. So we're close there. Now, what does it mean for a group of measurements to be accurate? Again, we're trying to figure out the true value of something, a property of some sort of substance or matter. That true value is here. And say, because, we might not trust our instrument very much, we're going to take a lot of measurements. Well, maybe one ends up over here, one ends up over here, one ends up over here, one ends up over here. All right, so we get 4 different measurements, but the group is accurate because the average is close to the true value. If I took the average of these 4, I would end up with an arrow much closer to this true value than any one of these is individually. This is one of the reasons we do repeated trials in chemistry and in any science class, is because as we're attempting to measure some true value, sometimes we'll miss high and sometimes we'll miss low, and we're hoping that those things are just due to some random noise and will balance out. Doesn't always happen that way. Now, what does it mean for a single measurement to be precise? So some of our instruments are more sensitive than others. we can have a graduated cylinder with more lines versus like a really wide beaker. Let's draw that. So here's a wide beaker that just might have a few tick marks on it. And then we might have a really skinny graduated cylinder, which has lots and lots and lots and lots of those tick marks on it. So this instrument is more precise because we're able to get a value for our volume that has more numbers actually in it. We sometimes call those significant figures. So a more precise number is something like 0.23519, and we'll say we're still dealing with volume, so we'll say milliliters. This is more precise than just 0.2 flat. All right, so more digits equals more precise. But that only applies when we're just dealing with a single data point. This is a very precise number. Is it accurate? We don't know. There is a difference here between precision and accuracy. Just because we have a lot of decimals doesn't mean that this number is necessarily close to the true value. All right, and then when we're dealing with repeated trials, then the word precise kind of takes on a different meaning. With repeated trials, precise means that the repeated trials are close to one another. So let's imagine we're throwing darts at a dartboard, and this represents taking measurements. If the darts are kind of all over the place, boom, 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 that is less precise. Of a group. But then we'll say our friend goes and they throw all the darts and they just end up really close together. So they're all like right here, 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 and here. Well, they're in a tight grouping, so that's more precise of a group. Missing a C in there. More precise group. But notice they're still not accurate because they didn't get close to the bullseye, but they're just close to one another. All right, so with dealing with a single data point, precision refers to just number of numbers, but with a group, it's how closely together the numbers are clustered. All right, we'll call that good for this lecture video. I'll embed a few more questions here for you to try concerning the things we've gone over, but that's that for this lecture video.